All right, welcome. We're going to talk about solving some equations using a process called extracting the square root. So this is not a new process for us. It's actually something that we've done before, and you can see here are some hopefully familiar looking equations where we did this. Essentially, extracting the square root is using the square root operation to undo x squared, right? To get rid of that exponent. The square root and the squaring cancel out, and we get x. Now, the reason it's called extracting, or at least the way that I like to think about it, is that when you square something, it doesn't matter whether that number is negative or positive, we get the same answer. And what I mean by that is negative 3 squared is 9, and positive 3 squared is 9. So the square root operation usually would only give us a positive answer. So the square root of 9 is 3, right? We only get positive 3. But that doesn't account for this idea that squaring has two different ways to get to 9. And so when we use it to solve, we have to consider that there's actually a positive number and a negative number that works for this. So this could also be positive or negative 3. And this is this extracting idea. So let's go ahead and look at some hopefully familiar looking equations where we do this. So x squared equals 100. To cancel out that square root, or sorry, the squared, the exponent here, we can take the square root. They cancel one another. We have to do the same operation on both sides, right? That's generally the way that equations work. So we take the square root of 100, you run that through your calculator, and you get 10. But the answer is not just 10. The answer is plus or minus 10. There is a positive answer and a negative answer. Again, because 10 squared is 100, but it's also true that negative 10 squared is 100. And this is that idea of extracting, where we get two different solutions, one based on the positive value of the square root and one based on the negative value of the square root. So plus or minus 10, which again represents two answers, positive 10 and negative 10. Okay, let's look at one more that's slightly more complicated, but again, in the realm of what we were looking at already. So here we have an equation with a little bit more going on. I have to get rid of this plus 30 here before I can take the square root. So I would take away 30 on both sides, and I would get an equation, again, a little bit simpler here. We get x squared equals negative 20. And some of you may be already thinking, oh, there's a little bit of an issue here. And there is, but we know how to solve it. So to get x all by itself, we take the square root, and there it is, right? Square root of a negative number. We know this solution is going to be imaginary. When we take the square root of a negative number, we have to take the square root of the positive version, and then we have to put an I with that. We're going to get an imaginary number. So if you use your calculator to simplify that, we get 2 square root 5 I. And the answer has to be positive or negative because we're kind of using this square root operation to kind of undo squaring, and so we have to consider that it could be a positive value or it could be a negative value. So two answers there, 2 square root 5i or negative 2 square root 5i. We could also put that I in the middle. That might be more familiar to some people here, right? We could put that I here instead. Same here. But either place is totally fine with me, wherever you decide to place that. All right, let's go ahead and now look at some that take this process kind of to the next level. So how is this the next level? Well, we can still use the square root here because we only have one instance of our variable. And we can use the square root to get rid of this particular exponent, right? So the same way here, we can use that square root to get rid of that exponent. Now, we can't do it when it's something like this. Again, I'm just making something up here. I can't take just the square root of a part of my equation, and I'd still have an x in there, right? I have to do the square root of kind of the whole thing, and so it doesn't work for equations in that form, which is why, you'll see these equations look sort of different than our factoring and quadratic formula equations that we were looking at before. Anyway, we're going to solve this one, and I'm going to talk it through. So I want to get rid of this. I want to take the square root of that. But if I take the square root of the side, I have to take the square root of the whole thing, and well, that's an issue. So I don't want to do that first. I want to first start by getting rid of anything that's added or subtracted. So that's always a key that we need to remember is if there's something that's added over here with this, get rid of that first. So we're going to take away 7. Go ahead and rewrite this. These cancel out. And now we have x minus 2 squared equals 16. Alrighty, now it's time to get rid of this exponent, right? Because this exponent is kind of trapping everything over there. Now we take the square root. And now it cancels out with this. And now we get this. Remember, square root of 16, when we're solving, this has 2 answers, has a positive answer and a negative answer. And what's different here is now I don't have just x all by itself. I have x minus 2. So kind of reading this, we're saying that x minus 2 is equal to positive 4 or negative 4. That's kind of 2 different equations, right? That's saying x minus 2 equals positive 4 and x minus 2 is equal to negative 4. You have a couple options here. You can continue to work with this as a positive or negative value, which I'm going to show, or you could split this up into 2 equations, right? X minus 2 equals 4, and x minus 2 equals negative 4. And this is how we're getting our 2 answers by solving these 2 somewhat simple equations. And in this case, right, if we kind of carry this forward, adding 2 to both sides, we get x equals 6. And then adding 2 to both sides, we get x equals negative 2. But I want to talk about this version over here. So I'm going to leave it like this. I'm going to go ahead and add 2 to get rid of that. And I'm going to add 2 over here. So by doing so, I get 2 plus or minus 4. And this, again, should match my 2 answers. Because if I do 2 plus 4, I get 6. 2 minus 4, we get negative 2. Those are our 2 answers, x equals 6 and x equals negative 2. Kind of interesting, kind of cool. You can leave that plus or minus symbol in there and then kind of simplify it at the end. All right, I'm going to erase some of this stuff here real quick. Do another example of that. I'll write the answers here. X equals 2, x equals negative 4. All right, or negative 2. Okay, so very similar problem that we're running into here, right? Small differences in it. We have a plus on the inside, a minus, right? But it's very similar. I'm going to start off by doing what I did before. Get rid of this minus 19. To get rid of minus 19 means I need to add 19. Okay, by doing so, right? Minus 19 plus 19, that's 0, cancels out. And now we have x plus 5 squared equals 80. Nope, not 80, sorry, 90. Alrighty, and then square root time, right? Because we need to get rid of this squared. It's kind of trapping the x inside of these parentheses here, so we can get rid of that by taking the square root. Cancels out our exponent. We get x plus 5 equals square root of 90. That is not one of our perfect square numbers, but it is simplifiable. It's 9 times 10, so we get 3 square root 10. But remember, actually, no, we get plus or minus 3 square root 10. Cool, right? And we're going to continue to work with that in that plus or minus state. I have to get the x all by itself still, so I need to get rid of this minus 5, take away 5 on both sides. And that's going to give us x, right, because this goes away, equals, and this may be weird the way that I write this, but I'm going to write it as negative 5 to represent that minus 5, and then plus or minus 3 square root 10. Here are 2 solutions, but this solution looks a lot like some of them that we did when we were using the quadratic formula, right? It is in this simplified radical form. And most often we would just sort of leave it like this. We'd consider this to be an exact solution, or sorry, rather exact solutions. These are 2 answers, right? That does actually represent negative 5 plus 3 square root 10 and negative 5 minus 3 square root 10. But again, I'm going to leave it like this because this is an exact answer. Anything that I would do further from this state would have to involve approximating the square root of 10, which is not an exact value. It's kind of an infinite decimal there. So again, we'll just leave our answer like this, -5 plus or minus 3 square root 10. In contrast to here, when we had whole numbers, right? When you have whole numbers, you don't need to stop at this point. You can actually perform those calculations and get really nice whole number answers. So small differences in kind of the way we finish them off. All right, finally, one more here. We'll take a look at this very last one. I think maybe you'll get the point of this here. So again, we don't start with the square root. That's always tempting because I got to get rid of that first, right? So don't start with your square root. Start by getting rid of anything on the outside of it, outside of the squaring here, right? So I'll take away 53. All right, that's going to become x plus 9 squared. These cancel out. And then 8 minus 53, that's a negative 45. Okay, now it's time to cancel out that squared. So we take the square root. And yeah, look here, square root of a negative number. We are going to get an imaginary, well, number involved in our solution. Okay, over here, we get x plus 9 because that squared cancels out with our square root. And, right, we got to take the square root of the positive version, and we got to stick an I on that. So we're going to get plus or minus 3 root 5. That is our simplified version of that. And then we'll put an I with that. Cool. Last step, this is very similar to what we did before. We're going to get the x all by itself, so we will take away 9. Again, I'm going to write this in kind of an interesting way. We'll have x equals, I'm going to write the real part here first, -9, then the imaginary part, 3 root 5 I. Nothing really else I can do with this, right? This is a complex number. We have a real part, and we have an imaginary part. This is our solution, or again, solutions, because this does represent two different answers, -9 plus 3 root 5I, and -9 minus 3 root 5I. But again, I'm going to just sort of leave it like this, put a box around it, leave it in this exact form. Don't want to worry about any decimal approximations or anything. Just stop right there. Alrighty.